Conversion between azimuth and bearing. Okay, our previous lesson, we learned that azimuth and bearing are horizontal angle, and it is used to describe the orientation of line. Okay, so azimuth is an angle ranging from 0 to 360 degrees, while bearing is an acute angle. Okay, so if a line is going in that direction, okay, so this will be the north, south, east, west of the initial point. So meaning to say, this is the bearing, okay, while the azimuth is this angle, okay, from the south branch of the meridian going to the line in clockwise direction. Okay, another, if the line is in this direction, okay, then that direction is defined as in terms of bearing. Okay, this is the bearing, and also this will be the azimuth. Okay, also if we have a line that is going in that direction, okay, the arrow is shown to represent that is the direction of the line. Okay, so we have also the bearing. Okay, this is the bearing, and of course this is also your azimuth. Okay, azimuth is an angle from the south branch in measured in clockwise direction towards the line. Okay, and another situation is that if the line is going in this direction, okay, so this is the initial point, this is the end point, so in that direction, so the bearing of that line is this angle, and of course the azimuth is this angle. Okay, so in other words, if you are given a bearing, you can compute the azimuth, okay, using this illustration. Or if you are given the azimuth, you can compute also the bearing of the line. Okay, so how are we going to do that? Okay, so this is the illustration. We will use this one. So let me draw a line. Okay, line in different direction. So for example, I have a line in the southwest direction. Okay, so this is gonna be the bearing. Okay, bearing. So let me indicate that B is bearing and alpha is the azimuth. Okay, and of course this is the azimuth. Okay, the other situation is that you might have line that is going in the northwest direction, so meaning to say from here to here. Okay, and of course this is the bearing. Bearing is the angle between the meridian and the line, so that is beta, the bearing. And by the way, this is the alpha. Okay, let me change my pen. Okay, that is alpha. Okay, so by the way, this I will call this one as point O. Okay, meaning to say the initial point of all the lines. And this will be my A. Okay, so I have line OA, and this is B. So this will be line OB. Okay, and therefore the alpha here is the azimuth of OA. So let me show here OA, and of course the alpha or the azimuth of OB is from the south. Okay, so from here in clockwise direction, stop to the line. Okay, so this is the alpha or the azimuth of line OB. Take note, OB, not BO. Okay, and then of course this beta here, this angle is the bearing of OA. So this is bearing OA, and this one is bearing OB. Okay, so let me discuss the formula in converting azimuth and bearing. Okay, so if we are given, let me show you the relationship between bearing and azimuth in the southwest quadrant, no? If in this quadrant. So we can say that this is your bearing, and this is also the bearing of OA. So we can say that the azimuth, okay, or the alpha is just equal to the bearing. Okay, so this is the relationship between the azimuth and bearing in the southwest quadrant. Another, if the line is going in the northwest direction, so O to A, okay, so this is your bearing, okay, and this is the azimuth. Now, what we are given here is either we have the bearing or the azimuth. So how are we going to show this? Okay, so if we look at this one, now this is a straight line. Okay, so in other words, it's a straight angle. The sum of the azimuth and the bearing is equal to 180 degrees. Okay, so therefore, we can say that the azimuth is equal to 180 minus the bearing. Okay, so we have here azimuth is equal to 180 degrees minus the bearing. Okay, so this is the general formula in converting the bearing to azimuth if it falls in the northwest quadrant. Another, how about if your line is going in this northwest direction, in this direction? Okay, so let me draw a line. Okay, for example, I have this line. So maybe this is point C. Then of course, this is the bearing OC. And the azimuth is from here, okay, from here or from this line, no, south branch, going to the line in clockwise direction. So let me show you here. So I have here that one, okay, that is the azimuth OC. Okay, so how to convert that one, bearing and azimuth? Okay, so if you look at, this is again 180 degrees. Okay, so from here to here, it's 180 degrees. And this amount, the small amount, is actually the bearing. In other words, if you are after of the azimuth, okay, so azimuth is equal to the 180 degrees plus the bearing. Okay, so that is the formula in solving the azimuth if you are given a bearing if in the northeast quadrant. Okay. The other line or other situation is that you might have a line that falls in the southeast. Okay, so let me call this as points D. Okay, of course, the bearing will be this one. Okay, this is the bearing of OD. Okay, that is the bearing. And the azimuth is from this line, no, going to, let me draw, okay, down to that direction. Okay, sorry for my drawing. Okay, so that is the azimuth OD. Okay, from the south branch, this line, south branch of the meridian, going in clockwise direction towards the line. Okay, so if you look at this one, actually, if you add the azimuth and the bearing, will give you 360 degrees. Okay, so in other words, if you are after of the azimuth, then and then you have the bearing, then you can say that azimuth is equal to 360 degrees minus the bearing. Okay. Okay, so you can use these relationships in solving the azimuth and bearing. Okay, so if you are given the azimuth in here, then you can solve the bearing. Okay, if you are given the azimuth also here, you can also manipulate this relationship or formula or equation to get the bearing. Okay, and likewise, if you are given the azimuth, so you just transpose beta or the bearing, and then you can get the bearing. Likewise, you have here, you can transpose beta here and then transpose alpha to get the bearing of the line. Example, compute the following azimuth into bearing. And there's a note here that azimuth is reckoned from south. Okay, so in other books, in international, especially international authors, azimuth is reckoned or referred from north branch of the meridian. However, in the Philippines, now when you submit a land surveys in the DNR, the concerned authorities, we recon the azimuth from the south. Okay, so we have here azimuth 225 degrees, 20 degrees, 345 degrees, and 90 degrees. Okay, so let me mark first on where are this azimuth, or where is the what is the direction of this line. Now what quadrant? Okay, so this is 225. So if we imagine, no, you have 225. So from here, that is 90, to that is 180. This is 270. So therefore, your line is somewhere in the northeast quadrant. Okay, so that is in the northeast quadrant. You have here, you have to use this relationship, which is alpha or azimuth is equal to 180 degrees plus beta. Since we are asked to solve beta or bearing, so we can get, no? So you have the solutions, or there's no need for us to show the solution. You have, that is, okay, so let me write solutions. Okay, for letter A, you have alpha is equal to 225 degrees, and we are asked to solve the beta, okay, or the bearing. So using this relationship again, okay, so you have 180, or that is alpha is equal to 180 degrees plus beta. Okay, so therefore beta is equal to 180 degrees oh no, correction. Okay, so that is beta is equal to 180 degrees minus the alpha. This is negative, right? So we are after to get the positive of the beta, so rearranging the equation, you have this one, beta would lead you, that is alpha minus 180 degrees. So this is a simple manipulation of the equation, so don't be confused. Okay, so we are given a value of 225. So we have beta therefore is equal to 225 minus 180 degrees. and that is equal to 45 degrees. Okay, so this is yet the bearing angle. So when we see beta or bearing, there should be a quadrantal direction. So this is, and this, it falls on the northeast quadrant. So therefore you have to indicate north, and then you have to indicate north, and then this is east. Okay, so this is the bearing of, or the equivalent bearing of the azimuth 225 degrees. Okay, another thing, you have B. Okay, for B, you are given the azimuth, which is 20 degrees, and asked to solve what is beta. Okay, so this is in what direction? So 20 degrees is this is 0, and then chuck chuck. Okay, so it's somewhere here in the southwest quadrant. Okay, so recall that if it falls in the southwest quadrant, bearing, angle, and the azimuth are just equal. So we can say, therefore, there's no need to show the solution. So therefore, beta is equal to the alpha, or beta is equal to 20 degrees. And take note, bearing must have a quadrantal direction. So this is in the southwest quadrant. So we have to indicate here south and then west. So this is the equivalent bearing for azimuth 20 degrees. Okay, so for letter C, azimuth is 345. Okay, so we have C, alpha is equal to 345 degrees, and we are asked to solve the beta. Okay, so 345 is somewhere. Okay, so we have 345. So this is 90, 180, 270, and this is, of course, it will go back to 360. So 345 is in the southeast quadrant. Okay, so we have to look, or we have to refer to this relationship wherein alpha, okay, so alpha is equal to 360 degrees minus beta. Okay, we are asked to solve beta, so we have to manipulate that one. Okay, so it could be, okay, so you have beta is equal to, that is transposed, that is 360 degrees minus the alpha. Substitute the values, you have 360 minus 345 degrees. Then it will give you 15 degrees. Okay, that is your beta. Again, you have to put the quadrantal direction. Okay, that is in the southeast quadrant, so of course you have to southeast. Okay, so this is the equivalent bearing of the azimuth 345 degrees. Okay, so another, you have 90. So 90 degrees. Okay, so where is 90 degrees? Where is 90 degrees? So we have to look at this illustration. So this is 0, and then you have to stop here. This is equal to 90 degrees. So meaning to say, it falls in this quadrant. Okay, so this is from here to here. Okay, so therefore, the azimuth, the bearing of that one, because it falls on, or it coincides with the quadrantal directions, or it coincides with the north, south, east, west lines. So that is equal to, the answer is, the bearing is equal to due, that is in that direction, right? So that is due west. Okay. Okay. So meaning to say, if you have 0 degrees, so meaning from here to here, it's just 0, right? So that is due south. If it's 90, that is due west. And then If it is 180, the line goes in that direction, then that is due north. Okay? And then if it falls in that direction, okay, it coincides with the east, then that is due east. Okay? And then of course, if it goes in that direction that is 360 or 0 degrees, then it is due south. Okay. Okay, we have here another example, or letter E. E, you are given the azimuth, which is equal to 325 degrees, 15 minutes, 36 seconds, and of course, what is the bearing or beta? Okay, so same thing, this is in the southeast quadrant, so we can use this relationship, or you have alpha is equal to 360 degrees minus beta, then beta therefore is equal to 360 degrees minus 325, and yeah, 325, 15 minutes, 36 seconds. So substitute, or you may use your calculator. Just want to show you how to use this one. So you have 360 degrees, you have to press this one, minus 325 degrees, again press the DMS sign or key, then 15, again key for the minutes, and 36 seconds. Okay, and then equal. Then you have this 34. Okay, that is 34 degrees, 44 minutes, and 24 seconds. Again, that is in the southeast quadrant. Okay, so the bearing is south, 34 degrees, 44 minutes, and 24 seconds. Okay, that is the equivalent. Okay, so by the way, this is in DMS, degree, minutes, and seconds. If you want to convert that one, or write, not convert, or write this one in degree decimals, you have to just press this key. This is the DMS key of your calculator. So just press it one. Okay. Okay, another example is the opposite. We are given the bearing and we are asked to solve the azimuth. Okay, so we have convert the following bearing to azimuth. It does not indicate whether the azimuth is from south or from north. So in this case, it is presumed that the azimuth here is from south. Okay, so we have here the bearings, north 25 degrees east, and we have north west, southwest, southeast, and the other one is due east and due north. Okay, so of course we have this relationship again. Okay, so this is northeast, so we have to use this relationship, that is alpha is equal to 180 degrees plus bearing. Okay, that is for northeast. Okay, we have solutions. Okay, so you have for letter A, that is north 25 degrees east. Okay, so using that, we can say that beta, or the bearing angle, is 25, and we are asked to solve the alpha. Okay, so using this relationship, because it's again in the northeast quadrant, so you have to say alpha is equal to 180 degrees plus the 25 degrees. Okay, then that is equal to 200, that is 205 degrees. This is the azimuth from south. Okay, okay, the equivalent azimuth of this bearing. Okay, same thing, you have the northwest. Okay, For B, you are given 25 or north 25 degrees west. So therefore your beta is again 25, and then the azimuth is asked or required. Okay, that is a northwest quadrant. So you have to use this this relationship, which is alpha is equal to 180 degrees minus 25. Okay, that is solving or simplifying. You have 180 minus 25 will give you 155 degrees. Okay, so if we are going to plot that, for example, for A, so you have that is in northeast, no? So you have, this is the starting point of the line, and then you have to make the meridians and the parallel. 225 is here. Okay, so that is the 205, and then this value is the 25 degrees. Okay, so for B pod, you have this initial point, and then you have to draw the cross for north, south, east, west lines, and that is northwest. So you have, or you have northwest, so in this direction, and this is the 25, and of course this is the 155 degrees. Okay, so it's simple. No, there's no need for you to memorize the formula, but just understand the concept. Another one is for letter C. C is southwest. Okay, we are asked for C. Let me write here. Okay, for C is south 25 degrees west. So we have beta, or the bearing angle, to be 25. Then what is alpha? Okay, so using this relationship that is in southwest, the bearing angle and the azimuth are just equal. So therefore azimuth is just equal to 25 degrees. Okay, next, D is southeast. Okay, so D is southeast. So you have bearing angle is 25 degrees and alpha is unknown. So that is southeast. You have this southeast, or you have to use this relationship. You have alpha is equal to 360 degrees minus 25 degrees. Okay, so therefore alpha is equal to 335 degrees. Okay, so you have that one. Okay, for E, that is due east. Okay, the bearing is due east. So if we are going to illustrate that one, so you have, this is your initial point. So if you go up, that is due north. If you go on the left, that is due west. If you go down, or in this direction, you have, this is due south. So if you're going to the right, that is your due east. Okay. So what is the azimuth of this line? No? That line. So you have to start from here and then in clockwise direction. So what is this? You have 90, this is 180, and then that is equal to 270 degrees. So therefore, azimuth is 270 degrees. Okay, so that is the answer for the due east, or the azimuth for due east bearing. Okay, another is due north. Okay, so due north, sorry for that. Okay, so this is again the initial point of the line, and then due north, so meaning to say you have to go in this direction, towards the north direction. Okay, so Of course, you have this, you have to draw this line, no? And then this is the south branch here. So going in that direction, that is 90, and this is 180 degrees top, okay? So therefore, the azimuth of due north is equal to 180 degrees. Okay. Okay, so we were able to get the bearing from the azimuth, okay? From the azimuth. And also, given the bearing, we were able to solve the azimuth, okay? So using these relationships, okay?